So, hello guys, this is our second lecture on BW series. Okay, so here we'll start with the Ohm's law and we'll see the very basic of DC network. Okay, we'll see the symbols, so you'll get an idea about about this BW. Okay, this is just the starting class. Okay, lecture number 2, but the first class you can say. In first lecture we just discuss how what are the topics we'll cover. Okay, see what I made here is I have made everything put here. Okay, you can just, if you don't want to put so much time here, you can just take the screenshot. You can, and you can revise your topics. Okay, so in my first video I told you that my aim is for the university exam. Okay, and you can assume this is a revision class. Okay, so let's start. Suppose first Ohm's law. Ohm's law we have will not go that much deeper. Okay, Ohm's law, in you will see in class or everywhere people will say V is equal to IR. Okay, that is Ohm's law. The proper way is to say I is directly proportional with the V. If we say it properly, whenever any potential difference is applied across a material, okay, the current flowing through that material is proportional to potential difference applied across its end. Okay, means whenever any potential difference is applied across any material, at that condition the current flowing through that material will depend on the potential difference. Okay, potential difference at both sides of that material. Okay, or both end of that material. In Ohm's law we actually say I is directly proportional with voltage. So we can write, one more thing is, this Ohm's law is only valid in constant temperature. Okay, Ohm's law is valid only in constant temperature. Because of that, the reason of that I will see here. I is directly proportional with V, so we can write I is equal to V by R. From here we can make so many formula. V is equal to IR. Okay, V is equal to IR. You will listen everywhere. Here 1 by R is the proportionality constant. Okay, this R is called resistance. Okay, resistance and resistivity. Resistance and resistor is different thing. Okay, resistance or resistivity is the property. Resistor is the material or the device. Okay, same like conductor. Okay, so R is called resistance. Okay, 1 by R is called conductance. Okay, R is directly proportional with the L, that is the length of conductor. Okay, we are saying R in we are taking reference one material. Okay, that's why length of conductor, we are taking reference for conductor. Okay, R is directly proportional with the length of the conductor. Suppose we have any conductor, the length of that conductor. Okay, and it is directly proportional with the cross section area. Okay, cross section area of that conductor. So we can directly write R is equal to rho L by A. Rho is the resistivity. Okay, so Ohm's law is clear. V is equal to IR. It's okay, nothing wrong in that. But if you still wants to say it properly, then we can say it I is directly proportional with V. Okay, there is nothing wrong if you call it V is equal to IR. So that is Ohm's law. Now the basic concepts of DC. Okay, we'll see some. Actually, we'll see here some few terms. What are these things? Okay. So first of all, circuit. Circuit is the interconnection of electrical components. Okay, where electrical components, mainly resistor, capacitor, inductor, and source, Okay, source or load, you can directly say they are connected in a closed loop. Okay, that we call it circuit. The network is also an interconnection of electrical components, but we always say network in a bigger size. Okay, network, all the circuits are subset of network. Okay, but network, this can be open loop or closed loop, but in circuits we mainly talk about closed loop. Okay, means let me draw. Okay, let me draw one. This we can call it a circuit. Okay, just one closed loop. Okay, if we add here, maybe you can call it a network. Okay, then node is the where two elements or two branch is connected. Okay, branch is represented branch represent the element which hold a element. Okay, element means we are talking about resistor, capacitor, inductor, and or maybe source. Okay, so node is where two elements or branch is connected. Suppose this one and this one. Okay, this one, but these two are, if no element is connected between that, this is a single element, single node. Okay, we can call it a single node, this one. If we redraw it properly, we can see that is a single node. Okay, node is where two branches or more than two branches is connected or element is connected. Then branches which hold a at least a element or component of electrical component. Okay, then a junction. Okay, junction is where more than two components are connected. That point is called junction. Okay, here this point, if we redraw it properly, you can redraw that one, that point. Okay, we can redraw this. This will look better. This point, that we can call it a node, we can also call it a junction. Okay, we can also call it a junction because 1 2 3 4 5 branches are connected there. Okay, so that is when the number of branches connected in a node is more than 2, we can call it a principal node, or we also call it a junction. Okay, when only two the element or branch is connected, we call it simple node. Okay, then loop is any closed path. Okay, loop is any closed path. Loop is any closed path. This also a closed path, means current will flow. This also a closed path. Okay, current will flow. So any closed path, that is called loop. And then mesh. Mesh is the smallest loop in a circuit or network under which no more loop can be present. Okay, here this one is here. If we start from any point, this is a closed path, this is a closed path. Okay, this one is also a closed path. So all these are, we can call it loop, but the small mesh is smallest loop in a network. So we can see here two small loop is there under which no more loop is present. So we have two mesh here. Okay, we have two mesh here under means we have two smallest loop here under which no more loop is present. So we can call it as mesh. Okay, these are very basic thing. during my lab exams, I have asked these simple questions in lab biograph. Students were not able to answer these questions. Okay, so this is a very basic thing, but it's important for your university exam. Okay, especially lab viva, these concepts you must need to know. Okay, then that is okay, number of mesh in a network is m is equal to b number of branch minus number of node plus 1. Okay, if you put this formula, you will get the number of mesh. Okay, then this one also we call it sign convention. Okay, we also call it sign convention. Suppose we have one voltage source. Okay, positive negative is written, positive negative is shown. If current is flowing out or leaving the positive terminal, then we call it discharging mode. Okay, suppose if current is entering as a positive terminal, okay, then it's in charging mode. Okay, the network element, we have so many types of elements: active, passive, linear, non-linear, unilateral, bilateral, lumped, and distributed. These are the main network elements you need to know. Okay, first, active elements and passive elements. Active elements means the element which can give supply for infinite time. Okay, this is basic definition, but it is not like active element. Battery also active elements, means which can give supply without depending on any other, you can say, source or element. Okay, that also comes in dependent source, but for here this active element is example battery or any voltage source, current source. Okay, passive element which always depend on some any other element present in the circuit. Okay, to give supply, means suppose capacitor and inductor, they can give supply, but it depends, they always depends on other component present in the circuit, on other sources or any other depends on any other voltage source or current source. Okay, active component and passive component. Active is who can give uninterrupted supply from any other form, suppose example battery or any voltage source, current source. Then passive, capacitor, inductor. Okay, then linear and non-linear. In electrical, we'll just simply say that linear means it follows the Ohm's law. Okay, linear component which follows the Ohm's law, non-linear which does not follow the Ohm's law. That's it. Unilateral and bilateral. Unilateral means current following. Suppose we have one component. This one is the component. If suppose current is flowing from this direction first, if current follow from this direction, whatever changes happen. If current follows from the other direction, if the changes are same, okay, if the changes are same, changes in current, voltage, or in power loss, okay, heat generation or everything, whatever it can include so many things. We can just say directly, simply, if current is following from both the direction and if the change is same, then it's bilateral. Okay, if suppose current direction from left to right to the element, if the change is not same with the when the current supply from right to left. Okay, that's it. Unilateral and bilateral means, bilateral means if we change the direction of current, the change the change means due to the direction of current there is no specific change. Okay, and in unilateral, it the changes due to current direction The changes depends on the direction of flow of current. Okay. Then lumped and distributed. Lumped is very important in network analysis. Okay. Lumped and distributed. Lumped parameter and distributed parameter. Lumped means, suppose for any circuit, suppose I have drawn here one circuit. I have drawn like, I draw it again. Okay. Suppose this one is one closed loop. Okay, suppose this one is one circuit. Okay, I have drawn like this. So this is a symbol of resistor. Okay, these are symbol of resistor. Two resistor is here. So lumped is, we are assuming the value of this resistor is concentrated at single point. Okay, at this point only. That is called lumped parameter. And distributed in practically everything, all are distributed. Okay, in practical the resistance is not only concentrated at this point only, throughout this whole part the resistance value is distributed actually. Okay, but this is impossible for us to do analysis and calculations by considering this whole part. What we do, we do network analysis by assuming the value of that particular element or component is concentrated at a single point. That is called lumped parameter. Okay. Then my motive is to keep the video simple and small. Okay. So that's why I am going bit first, and we are not going that much deeper things, because my purpose is only for this video is only for, mainly I'm saying other students also can watch, but I am making this lecture series by targeting only the university exam here, college university exams. Okay. Now we have source, we have different type of source. Maybe my hand writing is not that much good, but maybe it's visible properly. I am explaining. We have different type of source, independent source and dependent source. Same thing. Okay, independent means we have one source that does not depend on any other component present in a circuit. Okay. Then on the dependent source, a source which can give supply, but the value or how long it will give us supply, that depends on how much it will give us supply. That depends on any other component present in the circuit. Okay, that is dependent source. Okay, so in independent source we have ideal source and we have practical source. In dependent source we have voltage source and current source. Then in ideal source we have voltage source and current source. In practical independent source also we have voltage source and current source. Okay, then voltage source means which gives supply to voltage, and current source which gives supply to current. But in practical it is not possible that we have one supply and it gives us only voltage or only current. It's not possible. Okay, mainly what about the sources are present practically, maximum sources are voltage source. Okay, but it also gives supply of current. Okay, then voltage source, dependent voltage source. In dependent voltage source we have current dependent voltage source, we have voltage dependent voltage source. Okay, current dependent voltage source means this voltage source depends on current on this voltage source depend on the current of any other component that is present on the circuit. Okay, and current for current dependent source we have same current dependent current source, voltage dependent current source. For voltage, current dependent voltage source and voltage dependent voltage source. Suppose this one is current dependent current source, means that current source value depend on the current of other element or component that is present in the circuit. Okay, I think it's clear. Now we have symbols. So this is the symbols of galvanometer, just one arrow upside, and or we can write G. Then we can write ammeter A. Okay, then we can write voltmeter as V. Okay, this is current source. The arrow shows the direction in which way the current is following. Okay, then we have different type of voltage source. Positive, negative is given. This one is ideal voltage source. Okay, then we have a single cell. This one is single cell. One big line and one small line. Suppose I have given here positive and negative. If it is not given, then also the bigger line is the positive, small line is the negative. Okay, then this one is the multiple cell. Okay, we can call it battery. Okay, this one is ideal voltage source, single cell, then multiple cell. Okay, then R, L and C, resistor, capacitor and inductor. Okay, these are denoted. Resistor is denoted by R, capacitor is denoted by C, and L is denoted by inductor is denoted by L. These are the main three components in electrical. Okay, then this is AC. Okay, AC source, voltage source, current source. AC means periodic. Okay, it depends on only this part is AC, otherwise everything is DC. Okay, so that's it guys. For this first lecture only, we will come up with current division, voltage division, KVL, KCL in the next lecture. So follow this channel and bye bye. Enjoy your time.